To draw unit hydrograph, you need a gauged basin where you have a flow hydrograph or storm hydrograph or the hydrograph you needed. You need a meter over there that will actually measure discharge over a period of time. But there might be a basin where you don't have any measurement system. In that case, we use synthetic unit hydrograph method. What do we do? We actually compare the basin we have with another basin that is identical with our basin, and from that basin we get two parameters. One is CP, another one is CP. And for the guest basin we have, we actually derive CT and CP so that we can actually uh, draw a unit hydrograph for a unguessed basin we are interested. So this is not a direct way of drawing unit hydrograph. This is an indirect way. So how do we do it? We'll go one by one. We'll not describe theory too much. We'll do the math, and I will explain the theory a little bit. So first of all, CT and CP. CT is time lag factor, and CP is peak flow factor. Is that factor? Yeah, factor. So there are some ways you can actually find out CT and CP. You need a uh, time over time versus flow uh, data from a guest basin. From that, you can find out CT and CP. And from the CT and CP we have, we'll derive a synthetic unit hydrograph for a unguessed basin. So for that, what do we do? We find, let's say, let's say we have a graph over here. Let's say a graph is like that, and say the unit hydrograph we're interested in will be something like that, something like this, something like this. It will go like this. Say. So we have a peak over here. We call that QP, and verily we have we have here discharge and here time. And we have say rainfall is, has started over here. It has a rainfall like this. It has started like this, say like this. So we have TP, which is basin lag factor, which is what does it mean? It means when rainfall occurs, when rainfall occurs, let's say three complex rainfall occurs, and it has a centroid over here, and you have a peak flow over here, and you have a time gap between these two things. This we call that TP, basin lag time, TP. We find TP from the data over here. Later, what do? We find QP. We have a formula for that, and the formula is QP is equal to 2.78. If I'm not wrong, 2.78 CP. The CP we have over here, A divided by TP prime, and the TP prime is that. Later we have later we have, say, a base period. Base period means the time direct runoff occur. So we call that T, and we have formula for that, and this T is equal to 3 plus TP prime over 8, and it is in day unit. So we have T. So by that we have starting point, we have end point, we have peak point, we have TP. So what are the things we need? we need say the height is 100 this height, we get at a height of 50% of this value, let's say over here, and we get at a height of say 75%, which is this. And for this 75% height of qp, we get a width, and this width is something like this. We call that W75, and we call this width W50. And there are some formulas to find out these things. I'll tell you later. And these width actually represent the time. So here we can find out. Let's say I have 8 hours, so I will go 4 hour destination. I will go 4 hour destination. Let's say I have here 10 hours, so I'll go 5 hour this way. I'll get 5 hour this way. I'll shuffle that. Later I have these points, this point, these points, these points, these points. I have a ending point. I have a starting point. Later I'll draw a curve over here, and that will be my synthetic unit hydrograph. So let's do the math one by one. So first of all, the thing you need is TP, this TP. How do you find that? We call that basin lag time, and the value is CT multiplied by L multiplied by LC to the power zero point 0.3. So here L and LC is given. I just go over the theories, you'll understand how does L means and LC means. So if we have a catchment, we have its centroidal point. From the centroidal point to the point of interest where we are, for that point we are actually drawing the unit hydrograph. The distance is LC. What do you mean? How do I mean? Let's say you have a catchment over here, and say you are interested to find out the unit hydrograph for this point, and you have a centroidal point over here, so this distance is LC, and say this is your furthest point, so this distance is your L. I hope you have understood this. So here CT is given as zero point 0.9, and L is given as 32, and LC as given as 25 to the power zero point 0.3. So memorize the formula, CT multiplied by L multiplied by C to the power zero point 0.3. So you'll get a value of 6.7 hours. So you'll get the value in hours, 6.7 hours. So this TP is 6.7 hours. Later you want to get rainfall duration. Rainfall duration will be TP over 5.5. It is a formula, and you get 1.2 hours. But here look, we are interested for a rainfall event of 3 hours. So we need to modify the TP we have. So we'll get a modified TP prime, and that would be TP we have plus the TR, the duration we want and the duration we have got, over 4. The TR prime is in this case 3. So, and TR is 1.2, and you get a value of 7.2 hours. See, the TP in this case 6.7, and the TP prime modified is 7.2. So eventually the TP prime would be 7.2. Now you want to know the peak discharge KP, and I have written the formula here. So it is actually 2.78 multiplied by CP. In this case, CP is 1.8, and area should be in case of square kilometer. So in this case, did I make any mistake? Sorry. Area, no. 325 over TP prime. Here TP prime is 7.2. So QP would be 225.9 meter cube per second if we use this formula. Later you want to know the T. So the T would be 3 plus TP prime over A. Here the TP prime is 7.2. From that you will get one thing, that is your T you will get in days. So here the days will be 3.9 days. If you convert it in hours, you will get 93.6 hours. Okay, the important thing is that you want to know the width of W50 and W75. So how do you get it? Let's say you want to get W50. So W50 is 5.9, 5.9. Then you have a denominator and you have QP over area A to the power 1.08. Let's calculate this. I didn't calculate it earlier, so I'll cross check it if it works. So in this case, our 5.9 over the QP, here the QP is 225.9 and the area is 325 to the power 1.08. So you will get W50 as 8.7 hour. 8.7 hours. Later you will get W75. For W75 you have a very plain formula, that is W50 you have over 1.75. You have W50 of 8.7. If you divide by 1.75, you will get a value of 5 hours. So this is how you can draw the unit hydrograph here. Here the T would be 93.6. So this length over here would be 93.6 and the height of QP would be 2 to 5.9. You have W75, you have W15. You know the TP prime here. So this is how you can actually draw synthetic unit hydrograph